Hello and welcome to this video brought to you by Smart Edu Hub Mumbai. In today's video, I shall explain to you the concept of electrical power. Now, as you can see on the screen, there are two electrical appliances, and to the left is the hairdryer with a power rating of 1200 watts, and to the right is the electric iron with a power rating of 2500 watts. Okay, so now we need to understand what is this watts. Well, first of all, understand that the alphabet W represents the unit of power, which is a watt, and 1 watt, if I want to talk about 1 watt, it tells you 1 watt is equal to 1 joules per second. So that means what is happening in 1 second. So something about the energy is happening, because joules is what? Joules is a unit of energy and seconds is a unit of time. That means energy, time and power are related. So what is this energy then? This is the energy that is transformed per unit time. So when I talk about the word power, it means energy transformed per unit time. Now, what is the energy that is transformed? What energy transformations are we talking about? Well, to understand that, look at the devices again. You brought home the hairdryer with the intention of converting the electrical energy into heat energy, right? Because you want to dry your hair. Similarly, you want the iron to iron your clothes. So again, you're going to change the you're going to change the electrical energy into heat energy, right? So what is happening in this case? There are some changes happening. Some kind of energy is getting changed into the other form. So the energy change is said to be the energy transformation. I'm writing TR to show there's an energy transformation happening. Okay. Now when I say that the power is 1200 watts, meaning 1200 joules of energy, of electrical energy, are getting converted into heat energy in every second. And when I say that the power of the electric iron is 2500 watt, it means 2500 joules of electrical energy are getting changed into heat energy in each second. So if you notice, the energy conversion or the energy transformation is double of what is for the hairdryer. Now obviously you can't expect that in 1 second the hairdryer will send you the hot blow of air which is equivalent to an iron, because iron is very hot. It is going to iron your clothes. The things are different, material is different, your hair will burn at that kind of energy transformation. So therefore every appliance will have the power as per its use. So the power of a washing machine cannot match the power of a iron. The power of an iron can never match to the power of the hairdryer. And there are n number of examples that you can take in daily lives. So basically this is the meaning of power. So power is the amount of electrical energy transformed per unit time. And like I told you, the unit of power is a watt. 1 watt is 1 joules per second. So this is all about your electrical power basically. Now I've picked up a table, and the table is for a set of appliances like the DVD player, the lamp, the air conditioner, electric oven, etc. And the first column is giving you the power rating in watts. As you can see, the time is in hours, and the energy consumption has been asked to you. You have been asked to calculate the energy consumption. Now you know very well that power, the unit of power is a watt, and watt is joules per second. So our first job is to convert the time in hours into seconds. So whatever time is given to you, that you're going to multiply by 3600 to change it into seconds. Okay. So now, for example, look at the first appliance, which is the DVD player. if you have to find out the energy consumption or the energy transformation that has taken place, so you need to multiply power by time. Now power is 20 and time, you just calculated that as being 1 into 3600. So if you find the final answer, 36 into 2 is 72, and after 72 you're going to put 3 zeros. So this is the amount of joules. Okay, 72,000 joules of energy are converted per unit time or in 1 second. So now if I want to write this in standard form, it will be 7.2 into 10 raised to 4 joules. So this is how you calculate the energy consumption. If in the exam you've been asked, you're going to do the same thing. If time is in hours, you're going to convert it into seconds, because the power always means in joules per second, because watt itself means joules per second, and you have to keep the units same. Okay. Now I'll introduce to you another important unit, which is kilowatt hour. And why is it important and what is it? So kilowatt hour is a measure of electrical energy. Okay, so when I hear the word kilowatt hour, I'm not going to say it's power, though there's a word watt in it. The kilowatt hour actually is a measure of electrical energy. Okay, it's a measure of electrical energy that you've consumed, and all the electricity bills everywhere in the world will have kilowatt hour as a unit of electrical energy that you're consuming. So I've put up an electricity bill. It doesn't matter whose bill it is, which country it is. It's just for us to understand that I've highlighted that part, total electricity use kilowatt hour, and the person has used 4440 kilowatt hours last year. So when they're telling you that, they're telling the person that it is the amount of electrical energy that the person has consumed. Okay, that's the measure of the electrical energy consumed. So how do I define the term kilowatt hour? Kilowatt hour is the amount of energy needed to keep a 1000-watt appliance running for an hour. So if you have a 1000-watt appliance and if you keep it running continuously for 1 hour, so the amount of electrical energy consumed will be equal to 1 kilowatt. And if you want to convert kilowatt into watts, it is 1 kilowatt is 1000 watts. But remember, this is just the conversion of kilowatts into watts, and I'm talking about kilowatt hour. The two things are different, because kilowatt is just a unit of power. These are the units of power. So this is just, I'm telling you how to convert between a kilowatt and a watt. And when I talk about the kilowatt hour, I'm telling you exactly how much of energy consumption has taken place, and that is equal to running a gadget or an instrument of 1000-watt power for an hour continuously. Okay, so now if you have to find out the energy consumption in terms of kilowatt hour, how will you find out the energy consumption? And so if you want to find out the annual energy consumption for this vacuum cleaner, so first of all you need to understand how many hours per day is the vacuum cleaner being used. Well, it is used for 2 hours. How many days in a year is the vacuum cleaner used? For 52 days. That means once a week it is being used. And what's the power mentioned on the vacuum cleaner? It's 2000 watts. That means the W has to be capital for watts. So now that means if I want to calculate the annual energy consumption of this vacuum cleaner itself, so I can simply multiply the hours by the number of days in a year, and then multiply it by the power and divide that by 1000. Why am I dividing by 1000? So that I get it into kilowatts. So then finally, if I plug in the values, the answer will be 208 kilowatt hour. Okay, so this is how you calculate the energy consumption of an electrical appliance, the annual energy consumption. Okay, so this is about another unit, kilowatt hour, and it is also important from the exam point of view. You must know the meaning of kilowatt hour. Now I'm going to teach you how to use the power equation. Now there's another power equation which states that power is equal to potential difference into current. And to put it in symbols, I can say the symbols for the terms P P is equal to V into I. And if I want to know the units, for the power the units are watts. So watts is equal to volts into amperes. Okay, so I can say this is for the units. Okay, now I'll draw a series circuit here. There are two lamps connected, and this is my lamp B and this is my lamp A. And if I tell you that the potential difference, the EMF of the battery is 12 volts, and if I tell you that the voltage across the lamp B is 4 volts and that across the lamp A is 8 volts, and this is the direction of the conventional current. So in that case, if I want to find out the power of the power supply, how do I find the power of the power supply? Well, for the power supply, what's the power? Power is equal to PD into current. PD is what? V into I. How much is the potential difference? Potential difference is 12 volts. And after calculations, if I tell you that there's a 2 ampere current in the circuit, so it will be 12 into 2, which is equal to 24 watts. So the power of the power supply is 24 watts. If I want to find the power of lamp B, then it's going to again be V into I. Now what's the potential difference of the lamp B? It is 4. In a series circuit, you know, the same current flows through the circuit, so it's going to be 4 into 2, which is 8 watts. So 8 watt is the power for the lamp B or the bulb B, and power for the lamp A is again V into I, which is equal to 8 into 2, which is again 16 watts. So if you see, if you know the values of your potential difference and the current, you can find the power of the battery and of every component that is present in the circuit. Okay, now the next part is I'm going to show you how to calculate the energy that is dissipated in a resistor. So now I'm going to teach you how to calculate the power that is dissipated in a resistor. First of all, the word dissipated means wasted. So when I say the power is getting dissipated in a resistor, is it actually happening? Yes, because a resistor is offering resistance to the flow of electrons, and in the process the resistor is becoming hot and there is no use of that heat that is present in the resistor. So as a result, we are saying that because there is an energy that is wasted, obviously that leads to the wastage of power, and wastage of power is said to be power dissipation. So if you want to find out how much power is dissipated in the resistor, we can make use of an equation. I'll help you to derive the equation. So the basic equation of power is equal to V into I, but you also know V is equal to I into R, and so it becomes I into R into I, which becomes I square R. So we have another equation of power, which is P is equal to I square R. Now in the case of this resistor, the resistor has offered a resistance of 5 ohms. So we want to find out the power dissipated. I will say P is equal to I square R. I is my 2 amperes, so it's I square, which is 2 square. R is 5, so 2 square is 4. 4 into 5, which is 20 watts. So how much is the power lost or power dissipated in the resistor? It is 20 watts. Okay, now let us understand what will happen if I double the current. So instead of 2 amperes, if I have a circuit in which the current is say 4 amperes, and if I use the same resistor with a resistance of 5 ohms, so if I calculate the power, what will it be equal to? Power is equal to I square R which is equal to I square is 4 square into R is 5. 4 square is 16. 16 into 5 is 80. So the power dissipated or the lost power is equal to 80 watts. So did you realize something? What did you do here? You just now only double the current. So you doubled the current. And when you double the current, what happened to the power? What happened to the power? Power increased by 4 times. So initially if the power was 20 watts, it became 20 into 4, which is equal to 80 watts. So this is how to calculate the power that is dissipated in a resistor. Rather, you can calculate the power dissipated in any electrical component in the same way. So well, that's all in today's video on electrical power. And if you want to watch more videos related to the curriculum, please subscribe to my channel. Thank you.